All right, I wanted to make a couple of videos because I'm seeing some of the work that has been turned in so far, and just want to make sure you all know kind of what's expected and how to work through this stuff. This is a lot different than what we've been working with before. So you're going to have a warm up. Expectation is that you put your answers in your warm up, you solve them, and this is just going to keep you fresh on the things that you need to know how to do going forward into this unit here. So it says determine each equivalent ratio. So we're solving for some variable. And so you need to find out how many times 16 is multiplied to get to 48. And 16 times 3 is 48. So then all I do is multiply 7 times 3 and I get 21. You could also cross multiply and divide. Best thing is to check and see if you can multiply by a simple number first. And number 2, 9 times 10 gives me 90. So 5 times 10 gives me 50. That's T. Equals 1. Any number divided by itself is 1, so P is equal to 10. And then here, 1,000 divided by 4 is 250, so Q is 50. All right, I'm going to go over this real quick. All right, so we had getting started, and this here is just to get you thinking about these numbers. So we've got government agencies and civil rights groups monitor enrollment in universities, and it says use the findings of the study to write each ratio. So what I did was I wrote some ratios here. So our enrolled female students to the total number of students was 3/5. Total number of enrolled male students to the total number of students was 2/5. Most of you got these right that I saw that were looking. There were some errors here in this 3 and 4 on a couple of them I looked at. So it says the number of enrolled female students to the number of enrolled male students. So right here, this 5, right? So they should add up to 5. So we've got the 3 from the female over the male here. Here we're going male to female, so we're going to have the male on top and the female on the bottom. That's how you do those ones. All right. It says determine the number of enrolled female students for each given the total number of enrolled students. Explain your reasoning. So we had 15 total students, and we're talking about female. So I'm using this 3/5 that was on my other page for my female students. I'm going to multiply these by 3/5 to figure out how many we would have given that scenario. 3/5 times 15 is 9. You could have also simplified and went 1 and 3, and 3 times 3 is 9. It works either way. 3/5 times 250, 150 female students are enrolled. 4,000 times 3/5, so I have 12,000 divided by 5, we have 2,400 female students. From here, we needed to fill out this table, compare the total number of enrolled students to the number of enrolled male students. So I have 0, 0. If I had total enrolled 0, I would have 0 here. And again, it's 2/5 for our male. So 2/5 of 250 is 100. 2/5 of 600 is 2,400. Now this is going backwards, so we need to multiply 6,000 times 5 over 2, and we get 15,000. So it says explain how you calculated. I knew that I had a ratio, a constant ratio of 2/5, so I just multiplied 2/5 times x. Determine the number of female students if you enrolled students, if 800 enrolled students are male. So I used my calculations that I was doing here. You could have also used these here. You could have used your 3 over 2 or 2 over 3. It doesn't matter which way you do it as long as you know what numbers you're working with. So what I did, I had 800 enrolled students. That told me I had 2,000 total students. And then from there, I took 2,000 times 3/5 and knew I had 1,200 female students. But again, you could have used the other ratios. All right. The number of female students enrolled, Y, for the X, the total number of students enrolled. y equals 3/5 x. Now I'm just using again those same ratios from the other page. The number of male students enrolled for y for x, the total number of total students enrolled. Y equals 2/5 x. Number of female students enrolled, y for x male students enrolled. Y equals 3/2x. D, the number of male students enrolled, y for x female students enrolled. Y equals 2/3 x. Describe the similarities and differences in each of the correct equations. So they're all proportional relationships. They're in the form y equals ax, or you would maybe writing that y equals kx for constant of proportionality. And the ratio, a is the ratio of y to x, or y over x. And again, that could have been k. All right, number 5. Create graphs that display each ratio, then compare the graphs. So I have total students to female and then total students to male. So look at my graphs there. You should have something similar. Describe the similarities and differences of the two graphs. Both graphs pass through the point 0, 0, the origin. Both are straight lines. So going through the origin, straight lines, that tells me they're proportional. The graph for female students enrolled is steeper than the graph for male students. We've got more females enrolled than males, right? So it says identify the constant proportionality in each relationship. Again, that's just your K, 3/5, 2/5, 3/2, 2/3. And then 7 says identify the constant proportionality or rate of change for each graph in question 5. So that constant one with the female over the total is 3/5. For the male, it was 2/5. And I just calculated K, that constant of proportionality, using y over x. Sorry I'm going fast, but I know there was some questions, and I just want to make sure I hit some of them. I also worked out 1.3, and that was comparing speeds. So we have Deja attends college in another state. During summer break, she drives home from college to visit her family and friends. So we've got, she's kept track of her time that it takes her to drive from home to school, and she's recording her distance after the various number of hours. Her data is in this table over here. Does this represent a proportional relationship? So I had to do y over x, right? They were all the same, so yes, the ratio is constant. And if Deja traveled 0 minutes, she would travel 0 miles, so that origin would be part of my table if I went further up or lower. I got that 0, 0 would be on there. Here is a ratio. I've got 3 different ways depending on how you would have written it. I would have accepted any of those. And then our unit rate is per hour. That's 60 miles per hour per 1 hour. All right, now we've got a classmate, Timer, who attends college. He also drives home. He takes a different route. So we've got a graph for this one. Passes to the origin, straight line, so it is proportional. Who drives faster? So I just need to look at my unit rate. For 1 hour, Timer, he goes 50 miles per hour. So he is not going faster, right? Deja's going faster. She travels 60 miles per hour. We've got a third friend, Alicia. So she uses an equation, and hers is y equals 57x. Is that proportional? Yes. I have a constant rate of change, and I have nothing I'm adding or subtracting from there. It's in that form, y equals ax or y equals kx. Compare your 3 friends. Who drives the fastest? Deja drives faster. We've got 60 miles per hour, 50 miles per hour, and 57 miles per hour. And then I've ranked slowest to fastest. Timer, Alicia, and Deja. All right. I'm going to do another video for the next one.